What's up, YouTube? Welcome to the other Chris and his other basement. Maybe it's the same basement. We don't know. Have we seen the other side of that basement before? I don't know. Maybe we have. Maybe we haven't. Oh yeah. So, what are we doing here? Warning, I am not Marlin expert. I dabble. So what we're going to do basically is I'm going to walk through setting up Marlin for a Prusa. This is a Prusa Bear frame. We've ripped out the 8-bit INC board. So we removed the old technology. We put that away. And inside here is the BigTreeTech SKR version 1.4. Not the turbo, just the plain 1.4. Doing this for the turbo will be is exactly the same. I'll show you how to do that. But we're going to walk through step by step. And why are we doing this? Well, 32-bit is basically the future. I mean, there'll be better ones in the future. We'll probably get 64 and who knows. But right now, 32 is the future. Board manufacturers are shooting out boards left and right. I mean, between BigTreeTech and all those other guys and Duet and everybody. But Duet uses a different firmware. But and Marlin has been full head of steam. All versions of Marlin are going to move towards 32-bit. So why not? I mean, might as well. There will be a 32-bit upgrade for the Prusa Mark 3S in the future. I believe the Buddy board is going to move over. But until then, we can play, and there's some benefits. So, I mean, Prusa firmware has some unique things that we don't want to disregard. So they make things easier. So there's all these, like, helper things and... what is that? They basically make it easy. So there's a wizard when you first log in to do all the fancy stuff. There's your first layer, Z offset, your live Z calibration built in. So there's a lot of things that are just built in to make the process easier for everyone. And that's something we really can't add to Marlin. Well, I mean, we can. We don't have that. But we do get some cool benefits. So there's features that when Prusa moved over and did their own fork of Marlin that they don't get. So like we're just getting Linear Advance 1.5. Linear Advance 1.5 has been stable for quite a long time for Marlin. There's S-curve acceleration, not in Prusa Marlin. There's junction deviation, not in Prusa Marlin. There's X gantry leveling based on probing near each motor, Z motor, not in Prusa. So there's just features we don't get. Also, if you want to change anything on your Prusa, some things you can't do, like if you want a fancy touchscreen. You just can't add a fancy touchscreen. You'd have to code your own screen, because again, they've stripped it down, so it has the bare essential. So Prusa Marlin works with that screen and these motors, and you don't really want to push the Bondtech too hard. So what we have here is a basically stock Prusa. The only thing that's different is, I mean, I got the screen, I've got the stock motors. I got a Bondtech BMG with a 0.9 degree motor running at 32 steps. So this is running at 1660 E steps. Something you don't want to do on the Prusa because you'll probably skip steps. But we can do that because we have a more powerful processor. The SKR version 1.4 has a LPC 1768, 100 megahertz processor, expandable memory with a removable SD card, micro SD card, where all the memory or all the the firmware is stored. So you never have to worry about your firmware getting too big. It has 4 fan ports and 6 motor ports, but it only has 5 stepper ports, but it has replaceable steppers. That's the big thing, is as technology gets better, we're kind of stuck when we have these all-in-one boards like the INC, where it comes with TMC 2130 drivers, which aren't the best drivers. So they've got some shortcomings. This is the 2209s, which is like the latest and greatest besides the 5160s. We won't go too far into that. But if I want to add a touchscreen, easy enough. Just click a button. If I want to make my Z taller, really easy to change that in the firmware on Marlin. Not so simple in Prusa Marlin, because there's a bunch of things that's, the Z calibration just won't work. And so there's things that just won't work if you start changing little things on your Prusa. But if you have a base version of Marlin, you can do whatever you want. Hey, it's a 3D print Viking. So let's go ahead and start. So basically, you're going to want to watch Chris Riley's video on installing VS Code, because we're going to do everything in Visual Studio Code and getting it set up for Marlin. I'm not going to go through that. There's already a really good video on that. So everyone go to Chris Riley's channel, go through his Marlin 2.0 videos. This is just going to be a walkthrough on how to set it up. So I got my little fancy Rockford mug of water. No Rockford water was harmed in this. That is some bottled water, because we don't drink Rockford tap water. I've got a cheat sheet with all my changes here, so that way I don't mess up along the way. But we're just going to walk through nice and slow, and we're going to set up Marlin the way I do it. Again, I am not an expert in Marlin. I may do something completely wrong, and if I do something completely wrong, put it in the comments so that way I can update it and stuff, because I'll make more of these videos, because this is just a beta firmware, so things will change. There's a link down there where you can get the firmware that I've already done. It already works. So if you have a Prusa Bear and you want to put an SKR 1.4 in it, I got all that on the GitHub. So the GitHub link down there below my mug. If you go there, there's a link for the SKR firmware. There's already a compiled one, and then the 3 changes areas. So the config.h, config advanced.h, and also the pins. Because to get the pin to work, we have to change some stuff in the pins, which was actually pretty darn easy. So let's head over to VS Code. So let's jump. Well, I'm jumping. You guys are going to stay there, and I'm just going to hit the screen share button. So we're in VS Code. I do something different. I don't do this new project thing. Keith Bennet, who has been a major help with my learnings of the Marlin, says just go to File, go to Open Folder, and I have a folder called Marlin Builds. So let's actually hop over to that. Let's make a fresh start here. So you guys don't need to see that. Let's go to a blank one. So I'll go to a blank screen here. And in my downloads, I've got a stock Marlin 2.0.3. This is the one I'm going to build off of. I'm going to go ahead and copy this. And I'm going to go to my Marlin builds. And this is something I recommend for anyone. So if you have a working firmware, don't start messing around with your good firmware. Like I have this one, and then I have a stock build. And then, whatever. But so I'm going to do SKR version 1.4. And this is going to be for BMG. Oh yeah, that's right. You can't do that in that one. So we're just going to do SKR version 1.4 BMG. There's nothing else fancy on here, right? I don't have anything else I have to worry about. So this is going to be our build today. And we're going to paste all that nonsense over. This way we have a fresh build. Again, there's no point in destroying an already good firmware that you've built, because if you add something and you break it and you don't know how to undo it, it's way easier to go back. So here we are. We're going to File, Open Folder, and Marlin Builds, and here's our new SKR version 1.4 BMG, and we're going to open that folder. And this will just take a second, but it built. This is our folder here. And there's 3 things we need to start with, 3 things we need to edit. And we're always going to start with the config. So we go to the Marlin folder, and we hop down to configuration.h, And here we are. We have a blank configuration.h. You can make a version for this if you want. I leave that blank. But the first thing we need to do is do a author thing. So let's go ahead and put our name in there. So we'll do Chris Orkaki. And then this is where you want to write your description. So if you kind of make a bunch of folders and you don't know what's going on. So this is going to be a Mark 3S because it has the Mark 3S filament sensor, which we won't do today, but we'll have a separate video for installing that. So MK3S with BMG 2209 and anything else fancy on here? No, let's do BMG 2209. That way we know that this firmware specifically for a model that has a BMG. So let's say you have a different extruder or you want to do a Hemera or something like that. You can label this, that way you remember what this is for. And I'll put SKR in there. SKR version 1.4 BMG 2209. Not a big deal. Oh yeah, and then I also mark it with what, because I'm using a Pinda with this one. I do have another one with the BL Touch, so that way I can look and figure out what I'm doing. Show boot screen is fine. We're going to scroll down, and the first thing we're going to do is a custom... nope, we're going to do the serial ports, right? Yeah. We're going to do the serial ports. So we leave 0. We uncomment, which all that means is we're deleting these 2 backslashes. So we have serial port 0 and serial port 2 as -1. We're going to drop our baud rate down to 11.5200. The reason I do that is there's no reason it can run at 250, but if you're going to add like a TFT touchscreen or something like that, they tend to play better at a lower baud rate. There's no missing thing. Choose the board. Now this is hard and easy. You can memorize them, or you can go to source and... Oh, is it source or is it libraries? It's one of these. Source and pins and LP, yeah, whatever. So you can do all that fancy stuff, but we're only doing it for one board, so it's going to be board underscore BigTree underscore SKR underscore version 1_4. So that is the board we're going to use. If you have the turbo, you would go and find the board for that. Let's see if we can find it. You know, this is what happens when you're not an expert in this. It's not there. Is it under how? No. There's a section here that has boards, and you just got to find it. But I'm not that good at this. Again, setting up for the one thing. The next thing we can do is, let's say you're going to do multiple printers with this. You can set up a custom UUID, which you just go to this link and you will get a custom UUID. That way, when you try to add multiple printers to, like, let's say Repetier server, they'll have an ID. That's come in very helpful. We also need a custom name. So let's go ahead and change this, and we'll call this the SKR Mark 3 S version 1.4, and that's just the status screen. So that's going to show up. Why does it have an R there? So that's just going to show up on the LCD screen. So again, it's the stock Prusa LCD screen. Extruder's 1, and our filament size is 1.75. Unless, of course, you want to change that to a 3mm extruder. You can. It's pretty easy. We don't need to do anything there. We don't need to do anything there. This is all the easy stuff. This is just going through all the fun stuff and making sure we don't need any of it. So here's where the next section we're going to need to do, and that's thermal settings. So the Prusa uses a number 5. So the E3D temp sensor is actually number 5, which is 100K thermistor. So 5 there. Temp sensor bed is actually a 1, which is the 100K thermistor, epox, blah, blah, blah. Now, here's a section. We're not going to get into this one because I haven't figured it out yet, working with Keith on that. But temp sensor probe, so this has been added to Marlin. So if you have a Pinda 2 that has the temp sensor built in, you would change this to 1 and do some other magic, and apparently it works. I was messing with it yesterday and I couldn't get it to work, so we're just going to leave that back at 0. We're going to use our Pinda right now As a regular capacitive probe, no issue with using it like that. It's actually been consistent every time. Don't need to change anything here. Now here's a section I do change. I have noticed there's some false positives with the bed heating and such, so I do change some of these values here. So I change this to 5 and 8. We're going to do this in another section. 5 and 8. So basically the swing was a little bit, if it swings like 3 degrees Celsius downward when the fan kicks in on the bed, it would kick thermal runaway. So I just kind of up these a little bit. Don't go crazy, because if you go too high, you won't trigger anything. But it triggers great, so if I've pulled cords and things, and the stuff works. Your minimum temps, I leave these all at 5. This is another thing I'm not a fan of with the Prusa firmware. They set theirs to like 15 or 20, and my basement is 17C, so every time I wake up, all my stock Prusas end up saying min temp error, please heat up, which you can't heat it up. So you have to actually take like a heat gun to it and warm it up, which is annoying. All my other machines, I have edited that down so that way it's in safe zone. Max temp, 295 is the max on the Prusa extruder. And the bed is 120. It's technically 110, but you can get to 120. Not a big deal if you do that. Now, here is some fun stuff. So we're going to make our own default whatever. So we're going to change this to SKR version 1.4 Mark 3S. And we have some values here. And again, you can pause this if you're doing this live, at home. So 16.13. And these are values that I've done from PID Tuning, 1.1625. And a KD value of 56.23. And scroll down, PID temp. Of course we want PID temping of the bed. That is just something that you must do. So we're going to add a new section. So double liney thingies and SKR Mark 3S 1.4. And boom. We'll just copy these values here. Control C, Control V. And I've got values. Our values are 126.13. And the bed is going to be 4.30. And the next one's going to be 924.76. Now, I would still definitely run a PID tune after you, get this printer up and running. That should be the first thing you can do. But you can edit those values in here so that way they're always saved. So we'll just uncomment these. But these are base values that should get you going. From there, you can do whatever you want. But these are just good base values. That way you can run a PID tune before you start printing. Because you definitely should. Because everyone's, might have a copper block on there. That's going to be different. I have an aluminum block on this printer. My bed has, a big metal plate which absorbs more heat. So depending on what you have on there, it's going to change these values. So definitely run those. Let me go check. I can't see the chat while I'm doing this, so I'm going to hop on via the magical YouTube thing on my phone. So that way I have the chat. And all right. All right, we got Buttram in here. We got Greg, 3D Viking. Whoa. We got people in here. All right, we're going to keep going. 32 people watching. So again, if you need to stop this, again, we're doing this live, but when you're watching this, you can stop this at any time and save stuff. Cold extrusion temp, 170 is fine. PLA can extrude at 170. It might start chugging. So, you know what? I'm going to do 180. I think I have it at 170 saved on mine, but we'll do 180. Either's fine. Max extrude length. Basically, this saves you from accidentally spinning the wheel too far and extruding 2,000 millimeters of filament. So it'll just go, I can only extrude 200, sorry. We don't need thermal protection chamber. Define, nope. And let's make sure we don't need to do anything over here because we are doing, nope. We don't need to do any changes here. We don't need to do any inverting. Here's an important part. So we're going to install 5 drivers on our board. There's going to be 2 for Z, and then a Y, an X, and an E. The SKR version 1.4 does allow you to run both the Z off of one stepper. I don't recommend it because there's a really cool feature that we can do when we have one on each. So we're just going to ignore the fact that we can do that. So we're going to uncomment out what we need. So we need an X, we need a Y, we need a Z, we need a Z2, and we need an E0. And we need to put the driver in there, which is very simple. You can just look over here and find it, but it's just TMC 2209. And we can copy that. And we can just sit here and paste it over. There's probably a better way of doing this. I am not a coder. I shouldn't be teaching you this because I'm not good at it. But you know what? I'm doing it anyway. Sip of not Rockford water. So that gets us set up. We have 5 drivers installed. It's going to do the magic. It's going to unlock something in configuration.advanced.h or advanced.h. Let's see here. We don't need to do any end stop noise threshold because we're not using any end stops besides the PID, and we don't need to enable that. We will be using that magical thing. I already forgot. We'll get there. We're using that thing, that crash stall guard. We're using stall guard. So our excess steps per unit. This is defined by the size of our idler. So with a standard 1.8 degree motor, which is what your Prusa comes with, and using a 16-tooth pulley, which is what comes stock, it's 100 steps per millimeter on X and Y. Now, if you put a 0.9 degree on there, you're going to double that value because it's moving twice as much. 400 is the Z, and the extruder that I am using is a BMG, so it's a 3-to-1 gear ratio. So technically it'd be 415 E-steps at 1/8 microstepping. At 16 microstepping, it is going to be something fancy, but doesn't matter. Well, you know, I might as well say. So it's at 32 microstepping, it's going to be 1660. No, 830. But what we're going to do is, again, I'm going to set this up for a stock Prusa, so we're going to put 280 and then we're going to set the microstepping later on, but our stock Prusa is 280 steps. Oh, wait, we said BMG, so we're going to put 830 in here. We're programming this. So, yeah, 280 would be your stock Prusa. 830 would be your BMG extruder. Max feed rates. We do change the max feed rates based on some amazing math by people. So, max feed rate on the X is 200 and 200 on the Y. And the Z is 30 and 120 on the extruder. Next up is our default max acceleration. Trust me, it is a Cartesian with a heavy metal, well, the heavy bed with metal on it. 2000 is good. 200, and you can leave the 10,000 if you'd like. So, what's next up here? Default accelerations are going to be all 2000s. Why? Because we're running a Cartesian printer. And yeah, we can adjust these in Prusa Slicer. You can change these with some M something codes. Not a big deal. So one thing nice about 2.0.3 is junction deviation works again. So we're going to keep define classic jerk disabled. So if you remember, classic jerk is like a value that you'd set for X, Y, and your Z. We don't need those anymore. We would actually just set a extruder jerk, which we'll set to 3.5. This 5 is really high. And we're going to leave this junction deviation right here of 0.013. You can calculate it. So if you want to head to this link right here, and you can calculate your own junction deviation value. So it's all good. Let's see if anyone... Let's see here. No, YouTube is... I'm reading some of these chats. Turn the mic up. I mean, I can. Hold on. Let me turn the mic on. Main on. Okay. Turning the mic up. Yeah, the mic is showing a lower value than it should. Normally it's a little bit higher. So let me increase that slightly. How was about that? There we go. Okay. Back to screen capture mode. See, this is why I check the chat every once in a while. S-curve acceleration. We will enable that because that works again. And so these are just neat features. So what junction deviation does, you can read it, but basically something that's not on the Prusa is it just calculates how to take a corner without causing as much jitter. So it basically reduces ringing at corners. Very cool. S-curve acceleration. It uses a different algorithm, so that way when it's buzzing around super fast, it accelerates and slows down at a rate where you're causing less, jitter and less artifacting. So again, awesome. Yes, we're going to leave define Z-min probe uses Z-min end stop because that's what we're going to do, even though we're not using the Z-min end stop, and that's why we're swapping some things around. I tried it another way and it didn't work. I don't know why it didn't work, which is doing this one. I won't even go into it because we're not doing it. We're going to do fixed mounted probe because that's what it is. It's fixed mounted. No nozzles probe. No, we don't have a BL touch, which, by the way, was so much easier to work than the Pinda. But hey, we can't get everything. We don't have a sled. We don't have a rack and pinion. We don't have a smart effector. Probe distance. So this is the set distance where the probe is from the nozzle. They got this fancy chart here. So if it's right and in front of the nozzle, you would do a positive on the Y and a negative on the... negative on the Y and a positive on the X. The Pinda probe is going to be both positive because the Pinda is to the right of the nozzle and behind it. Our values are going to be 23 and 5. Awesome. So minimum probe edge, we want to go to 20. So basically keep the probe from getting within 20 millimeters of the edge. Our probe speed can go higher. We can actually go higher than this, but I am doing this for safety version. Our speed fast for homing is actually going to be a multiple. So we're going to put a little bracket around there. We're going to do a space and a times and a 4 and a bracket. So basically, our Z probe speed fast is going to be the homing feed rate Z times 4. And we're going to leave this Z probe speed fast divided by 2. Okay, we're going to do multiple probing because it's more accurate. And we're going to do one throwaway. And our clearances. So to keep this going quick, we're going to set our clearances to values that are known as 2, and 2, and 2. And we're going to define after probing to 5. And low point -2, negative 2020. We're going to install the repeatability test. So this will allow you to measure one point over and over and over again, and it'll give you a value of how accurate your probe is, which it can and can't be helpful. Oh man, we got 3D Jimmy. I started linear advanced recently. Yeah. Ideal humidity level of your room should be the 5. We don't need to do any of this. I don't think there's anything else we need to do here. Disable E factor, false, false, false. Ah, here we go. Our directions are going to be false, true, false. At least that's the way the Prusa is. And I'm wiring my board in this order. So if you have a Prusa motor, all of your connectors should be wired from top to bottom. Blue, red, green, black, and I'll have charts for this that I'll also upload to the GitHub. But based on the way I have wired them, and that's the way they're wired straight out of the Prusa cables in that orientation, this is the direction. If they end up being backwards, you just come back in here and flip these to true. Like if your X is moving the wrong way, you just change it to true, and it'll now go the opposite way or the way you think it is. We'll leave all these false because it worked for me. But again, if your extruder is moving backwards, heat up your extruder to 180, and then, extrude, go to the movement section, go to extrude, and then you can find out if you're moving forward and or backward. Easy enough. These stay all There's nothing else we need to do. Yep. -1. Ah, here we go. Print bed size. Our exact print bed size of the Prusa is 255, even though that's not the printable area. 212.5. Our X min position is 0. Our Y min position, on the other hand, is -4. Our bed size is bed size, and our height is 210 millimeters. Again, this is awesome. So if you wanted to, let's say, build this bear with a 400 millimeter Z-axis, you would just change that value to 400, and you're good to go. Pretty cool. If you want to put a giant long bed on there, again, that's all you got to do. So let's see here. We will turn off software end stops on the min for Z. I don't know why. I just followed one of Keith's things, and that's how he set it up. So we're going to go ahead and do it that way. We will define the soft end stop menu, so you can change and disable that upon your lovingly needs. Filament runout sensor, I'm going to do a separate video on that because I'll show you how to hook it up. I'll also do a separate video on how to hook up the PID to the board because it is not... It's not as straightforward as you would think. We will define bilinear. We will... let's see, do we do a restore after G28? We will do a restore after G28. I always forget what I'm doing here. We don't need the debug feature. We will enable the fade height, which is good. And enable mesh validation is... define. No, it's not. No, it's not. We won't do that. Don't mess with that. Leave it alone. So here's where we set our grid. So you can do whatever grid you want. Anything above, I think 11 by 11 ends up freaking out Marlin. So 7 by 7 is great. That's what Prusa uses on their high end. But you can do 5 by 5, and the Y one is copying. So, anything else we need to do here? I don't think we need to do anything else here. Nope. Nope. We're good. We don't do that. We don't do that. Bed leveling. We could define LCD bed leveling. Should we? Should we? Yes, we should define LCD bed leveling. So this will give us a bed leveling menu in the LCD. And then how many steps? You can change this. It's set to be very fine right now, which is annoying, but actually kind of neat. We'll define a mesh editing menu. So let's say you have a... this is off topic. I'll skip that. C Pro M script, nope. We don't need to do that. We will do some manual defining of the home. So 0. And this is based off of Prusa's homing. So when it's done homing, it should be at this position. Of course, we're defining Z-safe homing. So what this does is it probes dead center of the bed. So that way it can't accidentally probe off the edge or something weird. It will just probe off the dead center of the bed, which again, it's showing you right here. 1/2 of X bed size, 1/2 of Y bed size, which we've defined. So it's kind of neat. It's doing all this math for us. We don't have to do anything. And oh, calibration. You can enable skew correction. This is part of Marlin. I do not have it enabled. Prusa has it. They use special bits and stuff on the one for Marlin. You would actually print a cube. Don't worry about it. Okay, we definitely need EEPROM settings. So EEPROM is basically your ability to save and store settings and then change them later on. So if you want to change E-steps or whatever, you can M92, whatever. So we need this. We need persistent storage. So we'll leave that going. Keep alive. Yep, we got all that. That's good. That's good. Inch mode. No, we don't need inches. One thing I'm going to change is the PLA bed temp can be 60. And we don't really print much ABS, so we're going to put PET in there. And the bed for PET is going to be closer to 80. I'm going to check the chat and continue on my mission. Let's see here. All right, good. Nozzle park. Yes, we will enable a nozzle park feature. So this will basically park our nozzle where we tell it to whenever we do nozzle parking. And this is all fine. We don't need to worry about any of that. You know what? Actually, I'm going to lower this down. This has been a little fast for me when I have to change nozzle speed, when I have to do stuff. We don't have any cleaning features, so we don't have to enable that. Print job timer, yes. I do like the print counter. So this is something that Prusa has. Shows you like how many successful prints you've had and how many, how much filament you've done. I enable that. LCD, we're getting real close to the finish of the config.h. So LCD support is good. We don't change anything here. We don't change anything here. We do define SD support. I actually found this out the hard way that it's not enabled initially, so I couldn't use my SD card. And I was like, oh yeah. As it says, your SD card is disabled by default. Well, that's silly. But we'll enable that. SD support is good. SD check and retry. I always enable that. I don't know why. I think I watched a video from Chris Riley, and it's just what he did. Encoder step pulses is 4, and we don't need to do anything else there. Yep, nothing else there. Individual axis homing. That's one that I love to have. So this way you can home X or Y or Z separately. That way you don't have to just hit home all. I do prefer that. And we'll put our speaker on. You can change its frequencies and madness and stuff, but I don't know how to do that. Define discount rep wrap controller, because that's what the Prusa uses. So the Prusa uses a rep wrap discount smart controller. If you're going to use any other screen listed, you would just comment or uncomment, or yeah, you would delete the little lines, whatever. So that's all we need to do in the config.h. So let's jump over to configuration advanced.h. This is the harder one. This is the one where it's like, man, it's talking some craziness. So let me go into my little master file and see if I need to change anything in the beginning, and I don't. We need to scroll down a bit. Heat bed chamber, don't need to worry about that. Here we go. Here's where that thermal nonsense kicks in. We definitely want to change a few of these. I've noticed it. So I do the swing up to 8 degrees before it does anything crazy. And we're going to swing this to 8 degrees. And 8. And 8. Again, do not increase these too high, because if you really do have some issues, but basically if you don't have a good PID tune, this is nice. Or let's say you put again, since you can put whatever 24 volt blower you want on here, if you want to put a 10,000 RPM blower, if it swings your bed temp down past 8 degrees and then starts coming back up, this will just prevent it from freaking out and causing a min temp error. So again, be safe. Don't go to like 20, but this is good. This is good. We don't need any thermal whatever for the chamber, because we don't have a chamber. Don't need this. Don't need this. Let me scroll through my fancy notes here and make sure I'm not missing anything. Oop, we're getting close to something that I need to change. Scrolling down, fan. There it is. So our auto fan pin is going to be changed to P2_04. And that's it. That just says our extruder's auto pin is set to that. That pin, which is the only one you can set it to, unfortunately, is your second heater port. I set mine to always on, but if you want to plug yours into that heater port, you can. And it'll kick on at 50 degrees Celsius, as you can see here. Do we need to do anything else here? No. Don't need any case lights. Don't need any of that. Don't need late Z enable. Dual steppers. We do have 2 steppers defined for the Z. So that enables that. And we scroll down. We don't have a dual X carriage. But we do have to get to this bumping stuff. So because we have stall guard, and we're going to bump into this stuff, we're going to set that to 0. There's a little bug. It doesn't do good with double bumping and stuff. And that's good. And we're going to define home back off. So that way when it bumps, it backs off of each one a little bit. Don't need any of that. Don't need any of the BL touch section, because that... We don't need to invert anything. Oh, we've missed something. Here it is. This is my favorite thing. So because we have independent steppers, stepper drivers for our Z axis, so Z1 and Z2 have their own stepper driver, we can control them independently, which means if we want to level the X gantry, Prusa did a level X gantry by bumping the gantry at the top, and it would level it to that. But that doesn't mean it's perfect, because you don't know if you're just a little bit off. But what you really want to do, and we've known this for a long time, is you want to level your gantry to the bed. So if the bed is slightly tilted, you know, in the X coordinate, you're just making it more out of tune. So the best way to compensate for that is actually leveling the gantry to the bed itself, which you can do because you can probe a point closest to the Z-stepper on the left and closest to the Z-stepper on the right, and they'll adjust the gantry. It's kind of awesome. I've posted a video of it, but we're going to find Z-stepper auto align magic nonsense. And it took me a while to figure this out because I've never done it before. Basically, you delete this. This is for a third Z-axis. You can put more, but I just delete that. It works when I do that. And we need to change the value. So I like to use the middle of the bed. So my value is 35 for as close as I can get to the left side of that Z1 motor, and 105, which is about the center of the bed. That doesn't really matter, but the next one's going to be 235, which is as close as I can get to the far right, and 105 again on the Y, because I don't want the Y moving around. There's no point. I want to measure the same point. Center of the bed is the best. Everything else doesn't matter here. You can change the iterations. 3 seems to work. You know what? I'm going to do 4. I'm going to change it to 4, and I'll even test it on my own. And yeah. I'm good. That's it. So that's a really cool feature, by the way. I freaking love it. False, false, false. Yes. Stepper inactive time. We're going to make sure that these Z-steppers never turn off after inactivity. And why? Because they can shift. So if you level your gantry, and you always leave your printer on, if you accidentally turn off, your print ends and it just sits there, you can bump into it and it'll move the Z on one side and you have to relevel. Prusa doesn't turn off the Z, so we're not turning off the Z. It makes sense to me. Slow down, don't need any frequency limits, backlash compensation. I want to mess with that. Calibration G-code, I want to mess with that too. And we don't need any of this stuff. Ooh, we do need some stuff in LCD. Let's see here. Yes. Scroll. I think we enabled the scrolling. Did we enable scrolling? We should have enabled scrolling if we didn't. Scrolling through my list of things because I'm making sure I don't miss something. I think this is where the next part is. Maybe, maybe not. Let's see. Make sure we didn't miss anything. I don't think I did. No, I didn't miss anything. This is all, it's all stuff we can skip. Skippity-doo-dah, skippity-doo-dah. Scroll longer, status message, sir. Nope. LCD timeout to status, nope, nope, nope. SD, nope, nope. Menu add, nope. 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 Here we go. Scroll long names. And no, that's good. We good. And no, we could do it. I don't want to do it. Has graphical LCD. We don't have that. We don't have this. We don't have any of this. See, if you had a graphical LCD, you can be messing with all these stuffs. Leveling, we don't need to mess with anything there. Thermal probe compensation. This would be enabled if I added, remember that one thing I said I could have changed it to a 1? This would have been enabled so I can mess with it. Arc support's good. Don't need to mess with any of these things. That's just silly. Those are just automatically done by the chip. Don't need to do that. Extra fan speed. Nope. We're just skipping through stuff. This is great. This is my favorite part. All right, we're getting close. We're getting close to some drivers. So here's where we're going to do some driver stuff. So translating Prusa's magic is kind of interesting, but I don't feel like I've missed a section. Oh, there's got to be baby stepping. I think I missed something here. Hold on, let's scroll back up. I'm glad I'm triple checking. Let's see here. Probe target. Oh, yeah, linear advance. Pfft. Enable linear advance. Set your value at 0. That way it's enabled by your G code. Boy, I can't believe I missed stuff. That's just weird. Let's see here. Make sure I'm not missing something. I feel like I missed a whole bunch of stuff by scrolling. This is what I get for only doing this like 50 times so far, because I've programmed 3 printers with this board. Keep going. SD support. Yeah, that's good. That's good. That's good. Graphical, nope. Safety, nope. Linear advance, good. We enable linear advance. Definitely make sure that is good. Because if you don't do that, you're silly. Thermal probe compensation, arc support, probe targets, good. This is good. This is good. Buffers, we don't need to mess with buffers. I think this is advanced pause. Ah, yes, advanced pause. Okay. It is a long section. So this allows us to have almost like that. You know, Prusa has a load, unload. This allows us to do that. So that popped in now. Let's go find that in my little chart here. This is always the fun part, is scrolling through all the fancy things. So there's buffer, advanced park. So 62 is good. And we're going to do 116 for the unload feed rate. And 25 and 80 for the length. And again, these are all things you can change. These are just what I found through Keith and other people who have done Prusa style board swaps. So this is not my magic. Fast load feed rate 6, acceleration 5, and length is actually, I think, a little long. I'm going to go to 60. I have 70 written down here, but it tends to go a little long. And advanced resume pause. Ooh, look at me scrolling through my list. So 625, 350. That stays at 0. Ooh, we need this right here. So our purge retract is going to be a 2. And our delay is 5,000, 8, and 25 is good. 45 and 10. And we're going to do park head on pause. And home before filament change. Perfect. And add filament load and unload G codes. All right. See, I'm glad I went back and looked at that nonsense because I'm not so good. Let's see. Good, good, good. Okay. TMC. All right, let's go to the drivers. So this is the important stuff because we need to set our... Nice thing is we're using these in UART. I suggest you buying... If you have a BigTreeTech board, you should buy some BigTreeTech steppers. I'm using 2209s. I highly recommend their BigTreeTech 2209s with UART already enabled. Excuse me. But that means we can change our current and stuff from the menu right here in firmware or on the menu on the screen. So if you ever want to just like fine-tune stuff, we can. So our x-axis is going to be 500 milliamps. Remember, these are 1 amp full motors. We don't need them at full current. Our homing, what I found works best, is 350. Microsteps is 16. The rest doesn't matter. Our y-axis needs to be a little higher. I'm at 600 on the y. And my homing current that I found that works is also 350. And 16, yep. Our Z1 is going to be 600. And our homing current is going to be half of that. So Z current, put a little bracket there. Or parentheses times, no, not times, divided by 2, parentheses. Same thing here, we're going to do 600. And our Z2 is going to get a parentheses and a divide by 2, parentheses. So that just means it's going to use half the current. You can do the same thing. You can set up whatever you want. This is just from testing. Unfortunately, you cannot change the homing currents in the menu. I wish you could. If you did the math, you can by changing the total current, but that doesn't make sense on the X and Y because it might not work. So, and then our E-axis, I have a 1.4 amp motor on the X. I have found that 900 works best. This is going to be very different for you. If you have a regular Prusa 1 amp motor, about 550 is good. Our micro steps, I will leave at 16 on this one. On the Prusa stock, you're going to be at 32. So on a Prusa stock extruder, like a Bear extruder or something, you are at 280 E-steps at 32 micro stepping. Currently, if you have, like, let's say you bought a BMG, you have a 1.8 degree motor at 16 micro stepping, that's 830 E-steps. If you go to 32, you're going to double that. No, man, my brain hurts. Just go with this. For me right now, this is what I have to use. But since we're setting this up for a stock BMG, we're gonna go to. They use a 1 amp motor as well, so 550 is fine. And none of this needs to. Oh wait, there's actually stuff in here. There's actually stuff in here. I think it's getting close. Oh yes, stealth chop XY should be enabled. And yep, stealth chop X, Y, Z, and E is enabled. That makes it all silent. We need to change our default power supply to 24. There is one for Prusa. So if you want to use this, it kind of makes the clicking a little bit less. I'm using a mean weld 24 volt. So we will allow the motor driver status to appear, because I want to know, and where's the TMC debug? Define sensorless homing. Heck yeah, we want to do that. And here's where we set our stall sensitivities. See, that's what I was looking for. That's the word I was looking for the whole time. Sensorless homing. And what I found works right now on my setup is 100 and 100. But this may change for you, and you can change this from the menu if you'd like. There will be a menu in there. We will define square wave stepping, which is good for TMC drivers. And we'll do the TMC debug so we can change stuff. And I think that's it. I think that's it. So that is it for the configuration advanced.h. Let me see if anyone in chat has said anything about my craziness here. Rotating my screen so I can actually see. No, cancel. There we go. I don't think anyone... Yes. Tanner's correct. Chris Riley is the Marlin guru. So's Keith. He's the one who's been helping me. But, let's see here. So that's basically it for this board. So we've kind of walked through that. Now, there is one thing we need to change, and that's in pins. So I could never get... this working through the Z-Min. For some reason, the Z-Min end stop and the pin to probe just yells at me. I tried the same thing with the BL Touch. I just have to use a probe pin. So under pins, we're gonna do some changes here, and let me double check what that change is. There it is. So basically what we're gonna do is we're gonna use, and I'll do another video on how to set up the pin up, but we have to set this up to make it work. But we go to pins, we go to LPC1768, which is the processor that we're going to use. And we do have to do one more change besides this, but we go to the 1.4 board, and we're going to scroll down, and we're going to get to our, here we go, our Z-stop pin. For some reason, I have to do this to make it work. I don't know why, but this is how I do it. Now, it says Z-probe, when not using the Z-min pin, is going to be P0_10. The Z-stop pin, even though it's there, it won't work. I plugged the pin in there, and it won't read. It just says open. It won't trigger. I was able to do it by wiring the PINDA into the actual probe pin. So there's the ground and signal in there, and I use the power from the Z pin. So I need to change this to match, so 0_10. And this just says, hey, make the Z end stop actually that pin, and it works. Again, I do not know why, but it does. So just work with me here. And then our last change is actually going to be in platform IO-I, and that's to change the board or the chipset to LPC 1768. And now we got to make sure it builds. So we change that. Let's go back here. I'm not going to double check anything. I'm going to see if we did it correctly the first time. We probably won't. We might. So let's hit build. And it's building. Yep, it's building. It says some things. I have an error. And it's going to find a path. Oh, yeah. And then do it again. Usually it creates the path the first time, and it always bugs out. So let's see if it builds. All you do is hit that check mark. I don't know if I showed that, but I just hit the check mark to build, and it builds. So it's going to go through all the magic, and hopefully it builds. This is an exact replica, minus a few things, of what I already have shared on the fancy GitHub. Mind you, I'm not a GitHub expert. I'll learn how to be better at that, but share the initial stuff. This will help you at least walk you through and give you some explanations on things, so you can set up your own firmware for this. And this looks like it's going to build, so I'm happy about that. Once it gets to firmware.elf, that's when it's like, yeah, it's going to build. Don't worry about anything yellow. Those are just things. And this takes a little bit because it's got a bunch of stuff. But yeah, made it to firmware.elf. That means the next thing's going to be built. Come on, you can do it. Build it. Build it. There we go. So we got it. We now have a built firmware. We can go through and double check stuff. But for the most part, it's going to run. And it's going to run exactly what I have here. I mean, you can do all kinds of stuff. You can change not having a boot screen. You can not mess with this stuff. You can change the name. Definitely don't change the board, because that's the board that we're going to use. And I'll find that boards folder and go over how to do this for a turbo or something else. But this will get you going, and it's stable, and it works. So 2.0.3 is stable, works with S-curve acceleration and junction deviation and linear advance, and it's working. So I'm a happy kid. But those are all the changes. Let me hop over to, let me turn main back on. Hop over to here. Whew. Hack Monkey, you can actually re-enable that. So you can add a power loss detection. It's actually in the firmware in Marlin, so it's got a basic like Creality style, and then you can actually hook up the power panic. So the pin you'd use on the SKR, the Z Max pin is the power loss pin. So if you plugged up something that triggers it in there for power loss, it'll work, and you can enable that. Same thing with the filament runout sensor. I'm gonna do a separate video for certain things. Like I'll do one specifically for the PINDA because there's some wiring things that are different again. And also when I finally learned how to use temperature compensation, this troop waffle ejector. So yeah, I'll go through individual things that need more showing. I just wanted to get people a basic idea of how to compile. Yeah, I said 25,000. I'd shave it off. Or did I say 10? I don't know. I shaved like 4 inches off. But yeah, I'll do one on power zoom. I'll do one on hooking up the PINDA correctly. I'll do one on the wiring connection. But the firmware is more important. So most people can figure out wiring up things and plugging things into ports. Yeah, the purple black is super hot. But yeah, I'll run through the hard stuff. Like eventually I'll talk about this linear rail mod, and I'll talk about Ultistick, and I'll talk about wiring. Wiring things. But yeah, the wiring things, it was fun. I'm not a fan of JST connectors, but that's what they all use. So you can actually, the BigTreeTech sells a board with caps on it to give it extra juice for power loss detection that you can install. So I might buy that and test it out, and then have RC-CNC, who designed the nice board case here, make it a little bit bigger so we can put that cap in there and then wire it in correctly. That way, yep, you can have your power loss detection. And Amazon does sell the Prusa Power Panic module thing, which, you know, you could install that and use it. It's what it's labeled in. So let me pull it up again. I have this thing that shows me all the pins, but that's what it's using when you enable that feature. Let's see here, SKR 1.4 board, and yes, power detection failure is Z max. And then your filament runout sensor is X max for E1, and then or for E0 for extruder. So they're just basically dual purpose. So when you enable it in Marlin, it then changes that pin from being a X max, a Z max to a power detection pin. So I got the pin diagram here. You can go to the GitHub for BigTreeTech and look at the big diagram. So, yeah. Who else? Any other questions before? That's all I want to do is go over how to set it up, and it took 1 hour, which is great, so people can go nice and slow and follow through how to do the firmware. Of course, I made one boo-boo and missed, linear advance and the unload load feature. But other than that, it works. It homes. It does all the fancy stuff. It's printing. It doesn't. Oh, that's another thing. I gotta check the temperature. Where did I put my thermal cannon? Thermal cannon. Gotta check these temps. Oh, it says one. I'll change the title. 38. So it's been running for a little over an hour, and the max TMC temps are 40, and 30 on that motor, and 39 on that motor, and 40 on that motor. So we're doing good. We're not causing any craziness with the motors. I can probably turn down the current on the extruder and drop that down to 35 pretty easy. Probably doesn't need to be as high. Again, this is a 0.9 degree 1.4 amp, so I'm running it higher, but I think I can get away with much less. I could probably get down to like 800 or 750 milliamps, and she'll run. But those are little things. You know how to change it now. You can go back in that video and be like, that's where I change it. Now I got to figure out how to do the those little things where you like jump to this time to check this out. But yeah, that's it. I mean, it actually gets pretty easy. I'm glad it compiled on the first try. What's the advantage? So the biggest advantage is, well, there's advantages and disadvantages. So the disadvantage is you don't get the awesome Prusa built-in features like live Z calibration and the wizards and stuff. So those are gone. What you gain is a processor that can run much faster, tons of new features that just aren't ever going to make it to 8-bit Prusa firmware. And whatever Marlin comes up with in the community will be moved first and foremost to stock Marlin, and it may or may not ever show up on Prusa firmware. So the benefit the biggest benefit is literally you can do whatever you want. Like if I want to change anything on my printer, or you know what, I'm just gonna new drivers come out, or I just want to do anything, I can. With the stock Prusa setup, I'm kind of limited to whatever Prusa tells me I can do and can't do with my printer. Which, if you're just going to print, buy your Prusa and print. Don't mess with it. There's no reason to. If you're going to make something that's a bit bigger, let's say you want to do super high temp material. Going with this board is going to be way better than sticking with the INC, because you can just change whatever you need to change on this thing, and you've got the capabilities. This has 4 fan inputs. You can use standard 24 volt fans, not 5 volt 3-wire. You can use whatever screen you want. If you want a touch screen, pop it on. So you just have the ability to do whatever you want, and it's just a lot faster. So you can run prints faster. You don't have to worry about it stalling out. Like, what was weird is when I made a profile based off of my Prusa profiles, it ran 2 times faster. Infill prints so much quicker because those fast, long movements are easier to process. Plus, you know, S-curve acceleration and better linear advance and whatever. So, but yeah, let's see. I've been with all the work put in the Marlin 2 and use. Yeah. Swapping over to a 32-bit on a Delta is awesome. And now that this is out, again, this is just very basic setup for that, and you'll have all these fancy menu items, and you know, you can change things. So right now this is running a 0.6 millimeter nozzle, and it's, you know, we're just chomping through it. Motors are staying nice and cool, and no issues. I love it. This Bear right behind my head, this silver one, that's been running an SKR nonstop for quite a while. So, and it prints beautifully. Now the print quality does go up marginally again when you swap over this board, because the Prusa TMC 2130s, I shouldn't say the Prusas, the TMC 2130s have linearity issues. So, you know, you can pick better. Hey, look, it worked. And now I can take this ulti stick off, and it doesn't fall off. That's the best. One thing I learned is make sure your Pinda works before you do it. So yeah, if you do set this up, when you set your Pinda, get a little piece of metal. Don't let it probe off the bed. Piece of metal, make sure it probes on that. But I think we're good. I'm good. We did a good job, team. We went over the firmware, and I'm gonna continue messing around here, and I'll continue posting. The SKR firmware is already up. The GitHub link is below my cup here. So if you look down below the cup, there's a link. There's already a firmware posted. The one I'm using on this one right now is posted. You might need to change E-steps based on your setup, but you can do that with EEPROM. I put up the config files, the 3 that need to be changed, so you can just, you know, swap them over to your stock Marlin and make sure you enable LPC 1768 in the platform IO folder or file. So see if this thing works. It's a print in place. So this is Clockwork. His print in place thingamathing. Hey, it works. I now have a print in place clamp. Tolerances are good. This is at 0.3 millimeter layer heights too. Overhangs are good. So now we got a clamp. Clamp with flashing I got to remove. So again, thanks again, everybody. Stay tuned for more SKR videos. It will definitely not replace. It'll definitely not replace Chris Riley. If you want actual Marlin help and information, Chris Riley. Don't ask me for Marlin help. Yeah, Clock Spring. That's his name, I believe, on the Patreon. So print in place clamp. But yeah, but I will definitely keep everyone up to date on this project. But hopefully it'll be done soon. I got a bunch of people in a little beta chat, and we're all swapping our boards over, and we're all going to see what kind of stuff we can do, and we're going to keep pushing it. So other than that, you guys enjoy. Have a great rest of the week, and I will see you all somewhere. Maybe even Murph. I'll be there. I mean, I'll be at Murph, but I'll see some of you at Murph. So good night. Or I guess good afternoon. It is afternoon. Damn.